Okay guys, so here's part 2 of your video. Recapping number 12, we had 2x squared raised to the negative 4 power. We said that if we put a 1 here, we simply flip the fraction, put the 1 on the numerator, leave the bottom in parentheses, change the negative to a positive. So that's quite a few things going on, so please first make sure you understand that. Now, because this is 4 or less, I told you guys you have to solve them when the exponent is 4 or less. If it's more than 4, like 5, 6, 7, you can leave it like that. You don't have to simplify it. We're going to have to think about what this is saying. So the power rule. First of all, the exponent rule states that when you have two bases that are the same, you leave the base, but you add the exponent. So this is going to equal 2 plus 3, x equals 5. Okay? So when the bases are the same, you add the exponent. This is called the exponent rule. Okay? But the power rule is a little bit different. The power rule states that when you have a number being raised to another power, a power being raised to a power, what do you do in that case? So this is coming from lesson 53 if you want to go there in your book, or you can look it up in a little while. But if it gives you the example x, m, so any number x raised to the m power, and then that is raised to the n power. So we're seeing that the xm to the n power, it tells you have to take x and you have to actually multiply it. Okay, you have to multiply it. You're not going to just simply add them like you would in this case. In this case, you have two bases that are the same and you add them. In this case, you have a base with an exponent and you raise it to a power, so you have to multiply those two numbers. Okay, so you want to be really careful when you're doing that. Now, let's apply that rule. Okay, so we're going to take 1 over 2x squared to the 4th power. And we're going to say this equals, now everything in here is being raised to the 4th power. That means 2 is being raised to the 4th power, and x squared is being raised to the 4th power as well. So both of those are being raised to that power. So it looks like this. 2 to the 4th means 2 times 2 times 2 times 2. So 16. These have to get multiplied. You're not adding them, you're multiplying them. So 16 to the 8th power. 1 over 16 to the 8th power would be the correct answer for that problem. Okay? Let me do one more like that. Okay? So if I can find one. Another simple way to think about it is, like, look at number 14. Number 14 has 4a to the 3rd power raised to the 2nd power. So think of it if you have like 6 to the 3rd, right? That means 6 times 6 times 6, correct? Well, this means 4a to the 3rd times 4a to the 3rd. That's another way you can think about it. So you're taking this expression and writing it twice, and when you write it twice, you're showing how it's representative of each other, okay? Now, the only thing is when you do this, you have to be careful because you may think, oh, well, then A and A, they're the same, so I'm going to add. But you don't add them because they're raised to that power. That's why I don't really prefer to write it that way. Actually, if you do it this way, it might help a little. So then you say 4A, so 4 times 4 is 16. A, and then you're going to multiply 3 and 3, so A to the 9th power. 16a to the, I'm sorry, that is not right. Let me start over. Okay, so this would be 4a to the 3rd power raised squared. So you're going to square this one. So you're going to say 4 squared times a to the 3rd squared. I had a 3rd there. That's why it came out wrong. Okay, so then this is going to be 4 squared is 16, a to the 6th power. Or if you wanted to write it the other way that I did, it would be 4a to the 3rd times 4a. See, no, I don't like expanding it like that because then I'm going to end up writing the 3rd twice, and then that makes you think multiply. So don't write it that way. The better way to write it is to expand it this way and say 4 squared 8 to the third, because think of these as factors which can be separated. So 4 squared times 8 to the third squared. Multiply here, and then you take the a, and you're going to take 3 times 2, and you get 16. That's really important that you don't confuse the power rule with the exponent rule, okay? So please be careful. The power rule is going to apply when you have a parentheses and that value is being raised. In that case, you multiply it. When there's not a parentheses and you had something like this, a to the third, a squared, then you would simply add those because this is the exponent rule where they have the same base. I hope that that helps you with that lesson. Let me think if there's anything else you need to know. I'm going to do number 26 for you, and then I'm going to stop and you guys can try to figure this whole thing out on your own, okay? So number 26 says 2x to the fourth, y to the negative 4, z to the negative 3, all over 3x squared y to the negative third, z to the fourth. Let me check that one more time. 2x to the fourth, y to the negative 4, z to the negative third, 3x squared, y to the negative third, z to the fourth. Okay, this is a hot mess, okay? You're supposed to leave the answers with positive exponents. So first of all, let's look at our coefficients, 2 and 3. They cannot reduce. So our coefficients are going to stay in the same position that they already are. So I'm going to write 2/3. They cannot reduce. Then I'm going to take the x and the 4, and I'm going to put, if it's a negative, I'm going to move it, okay? So actually, I think the easiest thing to do, guys, is to put everything on top first except for the numbers. I think that's the simplest thing. So I'm going to take all of these exponents, and I'm going to move them on top, and I'm going to change the signs. So I'm going to say times x negative 2, the 2 becomes a negative 2. Then the y negative 3, I'm going to say y becomes a positive 3. The z to the fourth, I'm going to make a negative 4. So I just put these on top, but I changed it to a negative 2, a positive 3, and a negative 4. Now everything's on top, okay? Now I have a simple equation. The 2 and the third stay where they're at. Combine your like terms. So you have 4 and minus 2. So x, and I'm working in the numerator because I put everything in the numerator. So x to the second power. Then do your y's. Negative 4 and 3 would be negative 1. Z to the negative third, z to the negative fourth would be z to the negative 7. Okay? Next step would be to take your negatives and put them back on the bottom and change the sign. So the final step would be 2 to the third. X squared is already positive, leave it alone. Y is not, so it goes down here, and it would be 1, so you don't put it there. And z to the 7th. So that is your answer for number 26. Let me verify that. Yes, that is correct. So there's a couple of ways you could do it, but I think moving the exponents in the part of the top of the numerator, simplifying it, and then once you're done simplifying it, put the negatives in the opposite part of the fraction to make them positive is the easiest way. Okay guys, so that's it for your review for this. If you have questions, please again, remember your quiz will cover this lesson in its entirety. So ask a lot of questions before Thursday, okay?